Welcome to this video, which is about consecutive numbers. Let's start the discussion with a question, that is, which of the following are consecutive numbers? The first, that is 1, 2, 3, 4, 5, and so on. 1, 3, 5, 7, 9, and so on. 2, 4, 6, 8, 10, and so on. -1, -2, -3, -4, -5, and so on. And 3, 6, 9, 12, 15, and so on. The question is, which of the following are the consecutive numbers? So, the first one, that is 1, 2, 3, 4, 5, is consecutive number, and we can call this one is consecutive positive integers. The second one, that is 1, 3, 5, 7, 9, this one is also consecutive number. We can call this one as a consecutive odd integers. The next one, that is 2, 4, 6, 8, 10. This one is also consecutive number, and we can call this one is consecutive even integers. Then -1, -2, -3, -5, and so on. This one is also consecutive, and then we can call this one is consecutive negative integer. And the last one, that is 3, 6, 9, 12, 15. This one is also consecutive number, and we can call this one as consecutive multiple of 3. You see here, all the number are multiple of 3. Now start the discussion about the consecutive number, that is, what is consecutive numbers? The numbers that follow each other continuously in the order from smallest to the largest are called consecutive numbers. That is, we can call in a brief, that is, following in order without jumping numbers are consecutive numbers. We already discussed many types of consecutive number, that is, consecutive positive integer, consecutive odd integer, consecutive even integer, consecutive negative integer, and consecutive multiple of 3. Now, let's express the consecutive number with the help of variable. So, if n is one integer, then the next consecutive integer are n plus 1, n plus 2, and n plus 3, and so on. And the previous consecutive integers are n minus 1, n minus 2, n minus 3, and so on. Again, if n is one even number, then the next consecutive even numbers are n plus 2, n plus 4, n plus 6. As we know, the sequence of number is first one is even, then next one is odd, and after that odd number there will be a even number. So if n is one even number, then n plus 2 is next even number, and n plus 4 is then the next to the n plus 2, and n plus 6 is next to the n plus 4. And the previous consecutive even numbers are n minus 2, n minus 4, and n minus 6. Again, if n is multiple of 3, then the next consecutive multiple of 3 are n plus 3, n plus 6, n plus 9, and so on. That is, we get the multiple of 3 if we add 3 with this number n. If n is multiple of 3, then n plus 3 is next multiple of 3. And n plus 6 will be the next of n plus 3, and n plus 9 is the next of n plus 6. And the previous consecutive multiple of 3 are n minus 3, n minus 6, n minus 9. In this way, we represent the consecutive numbers with the help of variable n. And this variable representation of consecutive number is very important to solving the problem involving consecutive numbers. Now, problem solving about consecutive numbers. Here we solve some problem involving consecutive numbers. So problem number 1, that is, the sum of two consecutive integers is 55. What are the integers? To solve this problem, we have to represent the conjugative integer with the help of the variable. That is, the solution is let to conjugative integer be a and a plus 1. Here, if a is one integer, then a plus 1 will be the next integer. Now, according to the quotient, that is the sum of these two numbers, that is a and a plus 1, that is a plus 1, which is equal to 55. Now, solving this equation to get a equal to 27. So, the two conjugative integers are 27 and 27 plus 1, that is 28. This is our result. That is, two consecutive integers are 27 and 28. Now, problem number 2. The product of two consecutive positive integers is 182. What are the integers? Here, the 182 is the product of two consecutive positive integers. Solution, that is, let two consecutive positive integers be a and a plus 1. If a is one positive integer, then next consecutive positive integer will be next to a, that is a plus 1. According to the question, a into a plus 1, which is equal to 182. Now, we can write this one as a quadratic equation with variable a, that is a square plus a minus 182 equal to 0. We can solve this equation in many methods. If we apply middle term factorization, we can solve this one to get the value of a. And if we add 1 with that a, we get the result, that is two consecutive positive integer. Here we solve this equation with another method, that is the factors of 182 are 1, 2, 7, 13, 14, 26, 91 and 182. Within this factor, this 13 satisfies this equation, that is a square plus a minus 182. So we can say the factor which satisfies the equation is 13. That is, this 13 is satisfied this equation. If we substitute the value of a is equal to 13, this equation will be satisfied. Then left hand side and the right hand side will be equal. So the solution of this equation is a equal to 13. So our first number is 13 and the next number is 13 plus 1, which is 14. So we can say two consecutive integers are 13 and 14. Next, problem number 3. The product of two consecutive odd integers is 143. What are the integers? Here, this 143 is product of two consecutive odd integers. So, the solution is let two consecutive odd integers be a and a plus 2. We know the sequence of integer number. If any number is starting with odd number, then next to the odd there will be an even number. Then next to the even number there will be again a odd number. That's why if a is an odd number, then a plus 1 will be the even and a plus 2 will be again the odd. So two consecutive odd integer will be a and a plus 2. So according to the quotient, that is a into a plus 2, which is equal to 143. We can write this equation as a quadratic equation of variable a, that is a square plus 2a minus 143 equal to 0. We can solve this quadratic equation using the factorization rules, but here we solve it using the factor, that is the factors of 143 are 1, 11, 13 and 143. The factor which satisfy the equation is 11. That is, if we substitute the value of a is equal to 11, then the left hand side and right hand side of this equation will be equal. That is, the equation will be satisfied. So, the value of a is equal to 11. Odd integer is 11 and the next odd integer will be 11 plus 2, that is 3. So, we can say two consecutive integers are 11 and 13. This is our required result. If we take the negative factors of 143, that case two consecutive integer will be minus 13 and minus 11. Now problem number 4. The difference of square of two consecutive integer is 37. What are the integer? Here, this 37 is the difference of the square of two consecutive integers. So, we have to let two consecutive integers. So, let two consecutive integer be a and a plus 1 as previous. So, according to the quotient, that is a plus 1 whole square minus a square, that is the difference of the square of two consecutive integer, which is equal to 37. We can write this equation as a square plus 2a plus 1 minus a square, which is equal to 37, and simplify the equation to get 2a plus 1 equal to 37. Then the solution of this equation is a equal to 18. So our first integer is 18 and the next integer is 18 plus 1, that is 19. So two consecutive integers are 18 and 19. This is our required answer. Now problem number 5. Find two such least consecutive integers so that the difference of the square of them is a perfect square number. The solution is, let two consecutive integers be a and a plus 1. According to the question, that is a plus 1 whole square minus a square is equal to one perfect square number. As we can let this perfect square number as 1, 4, 9, 25. In this case, we just let this one as 9. We just solve this equation as a particular case here. That is, we take this perfect square number is 9. So, we can write a square plus 2a plus 1 minus a square, which is equal to 9, and simplifying the equation, that is 2a plus 1 equal to 9. So, the solution of this equation is a equal to 4. Our consecutive integer is, first one is 4 and the next one is 5. So, two consecutive integers are 4 and 5. If we want to justify the answer, that is the 5 is square equal to 25 and 4 is square equal to 16. So, 25 minus 16, which is equal to 9, which is again a perfect square number. Now, problem number 6. The product of any two consecutive even integer is divisible by 8. We just here see the proof of this statement. That is, the product of any two consecutive integer is divisible by 8. Solution. Let two consecutive even integer be 2a and 2a plus 2. If we take 2a is first even integer, then 2a plus 2 will be the next consecutive even integer. Now, according to the question, just take the product, that is 2a into 2a plus 2. We can write 4a into a plus 1. And we know within this a and a plus 1, 1 must be even number. And 2 is a factor of even number. So, within this a and a plus 1, there will be a factor 2. So, within this a and a plus 1, one number must be even and 2 is a must factor between these two numbers. So, if 2 is a factor and then multiplying with 4, which is equal to 8. So, 4a into a plus 1 is divisible by 8. So, we can say the product of any two consecutive even integer is divisible by 8. Now, problem number 7. Three consecutive odd integers are such that the sum of first and the third is 70. Find the integer. Here, there are three consecutive odd integers. So, solution is, let three consecutive odd integer be a plus 2 and a plus 4. That is, if a is an odd number, the next odd number will be after a even number. That is, if a is an odd number, a plus 1 is an even number, and again a plus 2 will be again a odd number. That's why three consecutive odd integers be a, then a plus 2 and a plus 4. According to the question, that is a plus 4, that is first one and the third one. Sum of the first and the third is 70. So a plus 4, which is equal to 70. So we can write 2a equal to 66 and the value of a is 33. So the integers are 33 and 33 plus 2, that is 35, and 35 plus 2, that is 37. So the required three consecutive odd integers are 33, 35 and 37. Now problem number 8. Three consecutive integers are such that 3 times the smallest is 14 more than the largest. Find the integers. Solution. Let three consecutive integers be a plus 1 and a plus 2. According to the question, that is 3 times the smallest one, that is 3 times the smallest one, that is 3a, is 14 more than the largest one. Here the largest one is a plus 2. So if we subtract 14 from 3a, which will be equal to a plus 2, that is the largest one, we can write this equation as 2a equal to 16, which will give the value of a is 8. So the integers are 8, 9 and 10. Now problem number 9. Three consecutive odd integers are such that the sum of the first and second is 31 less than 3 times the third. Find the integer. Solution is, let three consecutive odd integers be a plus 2 and a plus 4 as previous. If a is one odd integer, then a plus 2 will be the next odd integer and a plus 4 will be the next to this a plus 2. Now, according to the question, we can write, that is the sum of the first and the second, that is a plus 2, is 31 less. So we have to add 31 with this sum of the first one and the second one to get the value, that is 3 times the third, that is 3 into a plus 4. So we can write first one plus second one plus 31, which is equal to 3 into the third one, that is a plus 4. We can write the equation as 2a plus 33, which is equal to 3a plus 12. After solving this one, we get the value of a is 21. So our first odd integer is 21 and the next one is 21 plus 2, that is 23, and after this one, that is 21 plus 4, that is 25. So three integers are 21, 23 and 25. This is our required result. Now problem number 10. The length of side of a triangle are consecutive odd numbers. What is the length of the longest side if the perimeter is 45? Solution. Here the side of a triangle are consecutive odd number. We know in triangle there are three sides, so we can let three consecutive odd integer be a plus 2 and a plus 4, which are the sides of triangle. We know the perimeter of triangle, the sum of three sides. So according to the question, we can write a plus 2 plus a plus 4, which is equal to 45, which is given here. The perimeter of the triangle is 45. The value of a from this equation, we get a equal to 13. So one side is 13, the next side is 13 plus 2, that is 15, and another side is 13 plus 4, that is 17. Here a plus 4 is the longest side. So a equal to 13, then 13 plus 4 is our required result. So the length of the longest side is 17. This is our required result. Now problem number 11. Find 4 consecutive multiple of 5 whose sum is 90. The solution is, let 4 consecutive multiple be a plus 5, a plus 10 and a plus 15. We know if a is multiple of 5, then we get next multiple of 5 after adding 5 with this a, that is a, and then next one is a plus 5. If we add 5 with this a plus 5, we will get the next multiple of 5, that is a plus 5 plus 5, that is a plus 10. Similarly, the next one will be a plus 15. So a plus 5, a plus 10 and a plus 15 is 4 consecutive multiple of 5. So according to the question, sum of these 4 number, that is a plus 5, a plus 10 and a plus 15, which is equal to 90. The value of a after solving this equation, we get a equal to 15. So the multiples are 15, 20, 25 and 30. This is our required result. Now problem number 12. Find 3 consecutive even integer if their sum decreased by third is equal to 22. The solution is, let 3 consecutive even integer be a plus 2 and a plus 4. If a is first even integer, then next will be a plus 2. And after this one, there will be next even integer will be a plus 4. So according to the question, we can write, that is a plus 2 is equal to 22. That is here, if their sum is decreased by the third, that is if we take this sum, that is a plus 2 plus a plus 4, and we subtract this a plus 4, then we can cancel this a plus 4. So a plus 2, which is equal to 22. That is, the sum is decreased by the third. So in this case, we can cancel this third one. We just add first and second one, which is equal to 22. The value of a after solving this equation, we get a equal to 10. So the integers are 10, 12 and 14. That is, first one is 10, the next one is 10 plus 2, that is 12, then 10 plus 4, which is 14. This is our required result. Now the final one, that is problem number 13. Find 2 consecutive even integers such that the square of the second decreased by the twice of the first is 52. The solution is, let 2 consecutive even integer be a and a plus 2. According to the question, a plus 2 whole square minus 2a equal to 52. That is, the square of the second, a plus 2 whole square, is decreased by twice of the first, that is 2a, which is equal to 52. Simplify this equation, we get one quadratic equation, that is a square plus 2a minus 48 equal to 0. We can solve this quadratic equation in many ways, that is middle term factorization or factor rules. Here, using the middle term factorization, we get the value here a equal to 6 and minus 8. So the integers are 6 and 8 or minus 8 and minus 6. If we take the value of a is equal to 6, we will get the next even integer is 8, and if we take the value of first even integer is minus 8, then we will get the next even integer will be minus 6. So this is our required result.